So once again, welcome everyone to today's seminar about continuous in situ gas analyzer technology for emission monitoring and process control in the cement industry. This is the third session within a complete series about 6 efficient solutions for the cement industry and can be seen as a more detailed training in addition to our previous webinar, which introduced the different technology for continuous emission monitoring. In case you are interested in knowing more about our previous topics, please get in touch with me in order to receive a copy of the recorded session. By the way, this session today will also be recorded, and I will provide the video file and presentation slides within the next days to all of you. Coming to today's agenda, I will start by making a short introduction of today's presenters and experts. Then I will tell you a bit about SIG AG, the company we work for. Furthermore, we will give you once again a short overview about the different analyzer technologies and their applications in a cement plant. And then my colleague Tobias Egle will take over and go more deeply into the different applications of in situ analyzers for emission monitoring and secondly, process control. Finally, we will have a summary as well as our popular question and answer session. So please make sure to write your questions in the comment section on the right side. So who are today's presenters? My name is Felix Bartknecht. Within the SIG organization, I'm Technical Industry Manager for Infrastructure Industries, which includes also the cement industry, among others. And in this position, I'm responsible for the international coordination of our solution portfolio for this industry. With me is Tobias Egle. He's working as a strategic product manager for in situ gas analyzers at SIG AG in Germany and has extensive experience in continuous and mobile gas analysis. Within SIG, Tobias is responsible for the GM32, a multi-component UV in situ gas analyzer, which is widely used for emission monitoring as well as DeNOx and DSOx applications. And of course, we have again Siegfried Andres with us today. He's SIG's industry manager for building materials, which includes cement, lime, glass, asphalt, as well as the pulp and paper industries. With more than 20 years of experience, he is responsible for our international key accounts and sales in these industries. All 3 of us will be available for the Q&A session at the end of the webinar, of course. SIG is a German-based company and global manufacturer of sensors and sensor solutions for industrial applications. The company is active in the areas of factory, logistics, and process automation, with around 10,000 employees worldwide and global sales of about 1.7 billion euros annually. But what we are in particular proud of is our huge product portfolio comprising of more than 40,000 products, of which most of them are either used to protect production workers or the environment. Furthermore, we invest close to 200 million every year in research and development, which makes us one of the most innovative companies on the sensor market. As discussed in our last webinar, there are various technologies available to measure and analyze different gases and their composition. There are the so-called extractive systems, displayed here on the left side, which extract a certain amount of gas from the main exhaust gas stream via a sample probe and a heated sample line. The gas analysis itself happens in a separate cabinet by using hot wet or cold dry technology. And there's the in situ measurement technology displayed here on the right side, which will be today's topic and where the measurement is taken in the reaction mixture itself. We will hear more about this from Tobias within the next couple of minutes. But what I want to mention here is that SIG offers the complete spectrum of analyzer technologies, hot, wet, cold, dry, extractive, in situ, as well as dust and flow measurement solutions. The portfolio is completed with our own data acquisition system for emission reporting. So all of these technologies mentioned can be used for various applications, of which we have quite a lot in a cement plant. However, there's the necessity to distinguish between the so-called process gas measurements or process control and emission monitoring. Process gas measurements are, for example, kiln inlet, calciner, preheater, DNOx or DSOx, or even filter control measurements. Emission monitoring is needed at these stacks where exhaust gas or flue gas is emitted or discharged to the atmosphere. Emission monitoring is also needed where the compliance of emission limit values need to be checked in accordance with local regulations. And now let me hand over to and welcome Tobias Egle, who tells us a bit more about the in-situ technology and its applications. And as a short reminder, in case you have any questions, please type them in the comment section in the bottom right corner. Thank you very much.
Hello. Hello, good morning, everybody. Sorry, thank you. Hello and welcome everybody as well from my side. As Felix already said, my major topic is in-situ gas analyzers. So I'm really looking forward for your question. And before we go more into the in-situ gas analyzers itself, we will have a quick view about the different kinds of technology as Felix mentioned already. As SIG is one of the only provider of all three major gas measuring technologies, we will have a quick look into the different technologies itself. So we have the cold dry solution, which is typically consisting of sampling and a heated sampling line, followed by a gas treatment, which includes pumps, filters, coolers, and then in the final stage, the analyzer itself analyzes the gas under defined conditions, temperature, no water anymore. So the issue could be here that you get water during the conditioning itself. So you're not able to measure all gases with the cold dry solution. The second one will be the hot wet solution, where you get as well a sampling line and a heated sample line, a sampling and a heated sample line, but you analyze here hot gas, which means you don't need to cool down the gas, you don't get water, and you have less maintenance on it. So due to that reason, you are able to measure more components with less maintenance at all, but still you have a sampling and some kind of conditioning. With the in-situ technology, you are get rid of all the sampling and gas treatment at all, and you're really measuring directly where the inside the process. May we mute somebody? We have a lot of background noise here. Felix, is it you? Oh, thank you. So with the in-situ technology, you're really measuring directly inside the process itself. What means that for you as plant maintenance team or as project manager, you have low installation costs due to no installation of the gas sampling line. You don't need gas container or treatment at all. What means that in addition, you have low maintenance efforts and OPEX due to having no sampling and gas treatment, because about 70% of all analyzer issues are going in the direction of the gas treatment and the gas sampling. And the in-situ gas analyzers from SIG have an integrated self-test function, which results into a zero and span check. Therefore, you do not need any kind of test gases to do it. And with our direct measurement, we have no changes of the gas composition, and as well, you can measure cross-stack through the whole stack. So you have a high accuracy and a good representative measurement through the whole stack and not just a sample. And due to the reason we are measuring directly in situ, we have a very, very good response time, which leads to a perfect solution for process control in any kind of processes. Next slide, Felix. First, I would like to talk about emission monitoring. SIG offers a wide range of in-situ gas analyzers for emission monitoring, which we will see on the next slide. We have so-called multi-component gas analyzer, which is really unique for SiC as well. We have the GM32, SO2, NO, NO2, and a couple of others, the GM35 and the GM700. And we use different kinds of technologies to get to these kind of components. So if you do not need too many components at all for your SEMs, you can use just one analyzer. If you may need to have CO and NO, you make a combination of GM35 and GM32. And with our single component analyzer, we complete the whole portfolio with the Zircor series and the GM901. Zircor series consists of 3 analyzers. We have a very basic unit, the Zircor 100, followed by a medium class unit and the premium class unit, the Zircor 302. Next slide, please. As well, the in-situ gas analyzers from SiC gives you the possibility to be really flexible. So with our different kinds of process access, you can adapt the analyzer to your needs. For example, you want to have a representative measurement through the whole stack, and you have 2 platforms on both sides. You get access to the reflector and as well to the sender receiver unit. You can go cross-duct. If you only have one platform and it's a SAMS measurement with not a lot of dust and humidity, you can use the GMP probe, which is an open path probe. Gives you fast response time and not a lot of maintenance, but one access from the side. Or if you have high dust load, which we see later, you can use a so-called GPP probe. You can go up to 100 grams per cubic meter dust with that probe. Still good response time and low maintenance, but compared to cross-duct and GMP, it's more maintenance than the other. So we can really, during the project, adapt the analyzer to your local needs in your plant. And the Zircor 200 as an zirconia analyzer, is a probe version. There is no cross-duct version available. So you are going here with the standard probe version. Here you can see the overview how that works in general. Typically with our in-situ analyzer, we work with light besides the Zircor 200 unit. So we send out light with the sender receiver unit. It will be reflected by a reflector and transferred back to the sender receiver unit where we analyze the reflected light. As well here, if you use a probe version, your reflector will be in the tip of the probe. So if you have very aggressive gases, we recommend to go with cross-duct version because you do not have any contact at all with the process gas. If you have only one access from one side, you go with the probe version. As well, we have different kinds of materials, special stainless steel or anything else what you need to adapt if you have as well aggressive gases and only one platform available. Next. If you have to follow some kind of regulations, most analyzers are approved according to the European regulation by German TÜV or by Sierra according to the MCERTs. And with the GPP probe, you have the availability to follow the US EPA. As well, we have many local certifications like Russia, South Korea, Japan. So if you have special requests, feel free to contact Felix or your local SiC organization on the world. We can help you out if we could fulfill your local certification requirement for the SEM solution. In the next step, I would like to talk with you about NOx reduction and CO2 reduction. With the global awareness of environment, many cement manufacturers try to reduce or maybe eliminate their emissions. And NOx and CO2 becomes the most important topics for the next years for the cement industry. And as well here, our in-situ analyzers can help you to optimize your NOx reduction system or your CO2 carbon capture unit. In the first step, I would like to talk about the NOx reduction systems. Here we just finished a very good field test with very promising solutions, which I will show you within the next slides. General trend, as I said, goes to lower NOx emissions. Normally, the standard emissions are in the region of 500 to 1,000 milligrams per cubic meter, which is possible without special units. But in Germany, for example, since 1st of January in 2019, we have a dramatically decrease of NOx emissions to 200 milligrams per cubic meter NOx and 30 milligrams per cubic meter NH3, which is a challenging combination because typically you reduce with ammonia your NOx emissions, and you need to balance that in some way. And these two values are already challenging for some kinds of cement plants. And China stepped one step ahead with some local strict requirements of down to 50 milligrams per cubic meter, where a kind of NOx reduction unit in the cement plant is definitely required. In the next slide, we will see a pioneer plant from Germany, which did over the last 14 years NOx reduction to achieve the targets which the German government released 1st of January 2019, very early. So they started beginning of 2000 with primary measurements like low NOx burners, flame cooling, things you could do to reduce NOx. So they achieved 900 milligrams per cubic meter with it, which was during that time quite good. In the next stage, they started with an SNCR technology. So they installed it and commissioned it and get down to 400 to 500 milligrams, which is okay for the general worldwide requirements of NOx emissions. In a second step, because they have been interested in the potential of the SNCR, they overdosed NH3 or ammonia into their SNCR plant to achieve 200 milligrams. But what you see on point 3 here is the other side of this activity was that they got a slip of 180 milligrams ammonia for that. So this was not at all fulfilling the requirements of the local authority. So they moved back to an ammonia slip of 30 milligrams and 400 milligrams per cubic meter, which was perfect and good enough for that time. But having the future in mind, what this plant has been one of 2 pilot projects in Germany to reduce and fulfill the new or the regulation from 2019. So they commissioned and in 2010 until 2012 SCR plant, where they did optimizations and improvements, and finally in 2012 they achieved the first target with 200 milligrams and 30 milligrams per cubic meter NOx. So this is the way how a cement plant could get down to NOx. There would be maybe different kinds of solutions as well, and maybe one or the other could use just an SNCR, but the typical way it goes down is these stages: primary measurements, SNCR, and at the end, if you need to really go down, SCR plant. In the next step, we will see what happens to that. So as Heidelberg Cement is a highly appreciated customer and partner of SICK in many, many cases, the Heidelberg Cement Geseke plant in Germany has used an SNCR until 2019, like many, many other plants. But with the new regulation in Germany of 200 milligrams per cubic meter NOx and 30 milligrams NH3, they get to the next point where they needed to have a further reduction. And so they decided to install an SCR unit, which was planned to start in March 2019. The measuring point should be at that stage behind the ammonia injection and before the SCR. So why this measuring point? Typically at that point you can measure the full ammonia. The ammonia which is coming from the process itself, from the raw material, You can measure the injection, if you use the combination mode as NCR, and you can have the injection itself plus NO. So you can make a feed-forward control of your SCR as backup your SAM system. So Heidelberg Cement contacted us to find the best solution for them. By reviewing all the requirements they had, we decided to install the GEAM32. Looking back to our discussion in the beginning, fast response time, low maintenance cost, under challenging conditions, the GEAM32 was the perfect solution for it. So a GEAM32 typically consists out of a sender receiver unit and a probe version. In that case, we decided to go with a GPP version because it has a filter and keeps out the dust from the optical path. So we evaluate in the UV spectra, which gives you high accuracy, no cross sensitivity to other gases or water. And we use this kind of UV light to spread it on a spectrometer, which has 1025 diodes. So every single wavelength will be evaluated on a defined wavelength. This gives you up to 4 gases in real time, which is perfect for process control like SCR. But in addition, to keep your maintenance costs low, as I mentioned before, we have integrated filters which are approved by German TÜV and MCerts, that you can do your zero and span check without any test gases. So as well, low maintenance costs. And with our automatic alignment function, typically if you have vibrations in the stack, the reflected light may get lost on in-situ analyzers. So with all our experience, about 40 years, we integrated automatic alignment function. So the reflected light will hit this part, which you see up there, and a motor behind this mirror will continuously align the reflected light to give you a stable measurement. So you have low maintenance costs, low faults, and a long time stable measurement. And at the end, what we did in Heidelberg Cement as well, you can get an MPR on site and you can control and service your units from all over the world, especially during these very challenging times, a good feature. So you can get 6 service technicians on the analyzer. You can go on your own and evaluate what's going on if there is a topic at the analyzer. Okay. So when we installed the unit in Heidelberg Cement, we define a field test. So we did 2 targets. We want to show what's the time advantage you have for a process measurement compared to SAMs. So we found out that you have a time delay between the GEAM32 at the SCR and the MCS 100 hot wet from ZIG, which is between 2 and 17 minutes. NO is typically in a range of 8 to 10 minutes, and NH3, as it absorbs very strong on surfaces, is up to 70 minutes. In average, it's 12 minutes. So a real SCR control with a SAM system is without an additional analyzer not really possible. How do we evaluate it? You see here in blue the ammonia injection, followed by the orange line, which is the GEAM32, and the yellow line all the time back here is the SAM system when it reacts. So you make with GEAM32 a real-time control, and with the SAMs just a late relay and a short tip of the process itself. Okay. Second target was within 12 months to define what's the maintenance interval of the filter. Because typically a GEAM32 do not need many maintenance or no maintenance within 12 months. The filter gets dirty and may destroy your response time due to dirt, and 100 grams dust per cubic meter is really a challenge. So we compared the ammonia injection at the SCR with the response time of the analyzer. And for me as product manager, it was very exciting to see how good the GEAM32 performs under these conditions. It showed a stable response time within 20 seconds over a period of 12 months. This means for you, you install and commission this unit, it gives you a good result within 12 months without a lot of without maintenance, and during your yearly shutdown, you can make the maintenance on your GEAM32. So no additional work for you at all by installing this unit in your cement plant. As well, a real SCR control with a SAM system is not possible, as we have seen in the slide before. Ammonia is very challenging at all for this kind of measurement. And GM32 is currently used in many of the first SCR plants in the world, as well in China. So may have a look in the current Global Cement magazine. There will be an article from us with regards to that field test. In addition, with the information about the first SCR plants in China, where we have been part of the project as well. Felix was so kind and put the link in here. And in the next step, we will talk about carbon capture. Sorry, I need to catch some time. Yeah, carbon capture is so far not included in the best available technologies for cement and lime. Currently, the approach was to reduce emission for cement industry, increasing kiln efficiency, utilize alternative fuels. But 60% of the CO2 emissions are released directly from the processing of the raw material, not from the combustion. So by combustion optimization, you may not reduce your CO2 emissions. So a solution could be a carbon capture unit, which is starting pilot projects all over the world currently. In the next slide, I would like to show you how in-situ solutions helps you to optimize your, maybe in the future, carbon capture solutions. You can use a GM901 and a Zircor. In this case, it was a Zircor 100 to optimize your combustion efficiency. With the Zircor 100, this is the standard basic unit, but you can upgrade it if you want more performance with the Zircor 200 or maybe with the Zircor 302. And the cool thing on the GM901, it's an entrance unit for CO measurement, and you measure real CO. It is not just a combustible sensor or something like that. You really measure CO, and this gives you a perfect solution for your combustion efficiency of your carbon capture unit. And as well, you want to know how many CO2 your unit have stored, and therefore SIG offers, as well with the same features like the GM32, a GM35, where you can measure CO2, and this gives you a value how efficient your carbon capture unit is running in the process. Next. So in-situ technology from SIG offers you a wide range of solutions. So you can either go with a very low maintenance effort for your SAM system, but as well for future challenges like NOx reduction or CO2 reduction. The in-situ portfolio from SIG gives you the perfect solution because it's low maintenance and fast response time, which is for process control a very important solution. So thank you for your time. And I'm looking forward for your questions.
Yeah, thank you, Tobias, for your very valuable, detailed, and informative contribution. Now we will come to our Q&A session. So let's check out what our audience would like to know.
So, hello.
Thank you. So in case there are no questions left, I also would like to say thank you to all our participants for joining today's webinar about in-situ gas measurement technologies. Thank you also for your questions and active participation. In case there are any open points, you're very welcome to get in touch with us, of course. And well, here, our next webinar on hot, wet, extractive, multi-component emission monitoring solutions will be on Tuesday, May 5th, so next week. I will send you the sign-up details within the next days, and will appreciate if you will also join this session too. So what's left to say is thank you all. Thank you especially Tobias for joining today's session and answering all these very interesting questions. Have a great week, stay healthy, and see you next time. Thank you.
Thank you. See you next time. Bye-bye.
Thank you a lot.